So now in this video we're going to look at some transistors right here. So this looks like one of these transistors, but it's not. To begin with, we'll look at the transistors. I took them out of this kit. I just took them out and did a little testing on them earlier, so they're not completely brand new, but pretty close. So 2N2222 and 2N3904. We got a couple of 2N2222s and a couple of 2N3904. So they're both NPN type bipolar junction transistors. I use one or the other, pretty much exactly the same for all the circuits I use, unless I'm going to exceed 200 milliamps of current from collector to emitter. That is the limit for the 2N3904. So if I'm getting close to 200 milliamps currents, I'll just use the 2N22. Otherwise, they behave pretty much exactly the same for most basic circuits. So there's probably specialty circuits where you need the 2N3904 instead. But I don't make any circuits like that. So, in any case, the thing we're going to look at, we're going to put a set current from their base to emitter, because that is what determines how much current can go from collector to emitter. And so to do that, I have a constant current source, adjustable constant current source component here. So it's not terribly easy to read, but right there, LM334, right there, and it's Z. So that probably means it's improved from the original version, but I don't know how. But in any case, V plus is the left pin, which is now at the top, and that is to this jumper there. V minus is to that jumper to make measurements easy and not clutter stuff up so much. And here we have a 6.8 kilo ohm resistor. So with that value of resistance, that's how you set how much current this is going to pass with this resistor here. And only this resistor, as long as you have enough voltage to provide that current for whatever else is going on. But in any case, that'll give us about 10 microamps of current. So we can look at that right now. And there you can see. So it's not exactly 10, but close enough. We're just going to say 10 to make the math easy. So now, first let's grab a 2N3904. There's two of them right here. And I did accidentally put them in backwards while doing a test run of this video earlier. So they're not completely new. I don't think that damaged them in any way though, but you never know for sure. So 2N3904. So left pin is the emitter, middle pin is the base, right pin is the collector, so we want to turn it this way. Emitter towards bottom, base in the middle, collector on top. And that is probably why I had them in backwards. I just set them in the same direction as that one without thinking. So I got the base right to that jumper. And now we're going to see again, we're still at microamp because I know it's safe. If you're not sure, make sure you put it to milliamps to begin with and measure the current first. And if it's less than 1, then you can go to microamp. And there you can see that's actually 0.01 is what we expect, but that is hard for it to get an accurate reading at that setting, down to that fine of a point. And so we go to the microamperage. Now you can see it's a speck above 10 microamps, but we're going to make the math easy. Just say 10 microamps. So what we can do is it's better to put a resistor. In fact, let's do that first. We're going to put a resistor from collector to the positive rail. So I have the power supply set to 5 volts and 60 milliamps of current maximum. That will help prevent short circuiting anything and damaging it. So with 5 volts though at the rail, 100 ohm resistor. Now we definitely need it at milliamps. We expect about 50 milliamps of current going through the resistor, and then now it's going to go through the meter. It's going to bypass everything else. And 50 milliamps right there. If you're worried about that, you can just move this over here. But right there, it had no other current path right there. So let's put it back. And now with milliamps, we already saw just with the current source we had about 10 microamps, so 0.01. Now we're going to measure the current. So the two currents are going to add up. That's how transistors work. And there you can see we got about 3.55 milliamps basically, which is about 355 times the current that we put from base to emitter. And so that was 3.55. I'm going to swap this resistor. We're going to put 10 times the current through the base with a 680 ohm resistor setting the current. So now we're going to have 100 milliamps of current. So I expect about 35 or 30, about 100 microamps. I think I said milliamps. Is going to be coming out of the current source, and it's going to hold that current. We're going to get about 355 times, so probably 35.5 milliamps current approximately. And there you can see it's close. And as the component warms up, it's going up. So this is not stable, as you can see right there. But we will pluck that out. So lower currents are more stable. So the gain does change as current changes. So there's a 0.1 milliamps. Again, it's more accurate to go to the microamp setting. Right there. And the only time I have to move the probes for this meter is for high current. So I can just leave the probes there, quickly change. It's auto ranging, so it quickly sets the setting. So that's the main takeaway. And let's put the resistor back. So we had 335.5, but it kind of shifts as the component warms up, as we saw. So here's another 2N2904 and 3904, and I must put them backwards, and we want to be in the milliamp range. There we go. Now you can see we got about the same current right there. So that is also a 2N3904, and we'll look at that 2N3904. Now we're gonna grab a 2N2222 right here. 2N2222, and just plug it in the same spot. Now we expect, since it's a different component, this is also a 2N2222, we expect a different current because the gain should be a bit different. Plus they can be a bit different even with the same component. So with this setup we had 35, or it looked like about 32 milliamps of current. And there you can see now it's lower, 25. So it actually has lower gain right there, 255 basically times. And as you can see, as it warms up, it's passing even more current. We already saw that this is also a 2N2222. And so right there, we have that current there, a little less than 26 milliamps. So about 260 times basically what we were setting, 0.1 milliamps of current. So 25 is about 250 times larger than that. Now what we're going to do is, I accidentally put them in backwards before, as I mentioned before. So I had the emitter to the positive side of the circuit and the collector down towards the bottom. And first we can look, it's not going to affect the, now it's the base to collector current, because it's also like a diode, but it's not made to operate in this direction. And so what we're going to do, put the resistor back. So even though so far it appears to be working the same, it's still going to pass current this way. I don't think it's going to damage anything either. But now you can see we're only getting about 10% of the gain we were getting before. And with this lower current, it looks pretty steady too. So that's with the 2N2222. I'm going to turn it back the right way. I'm going to grab one of the 2N3904s and put them backwards. So this is a really easy way, if you have a, especially if you have a constant current source, to even if you don't have one, you'll probably get these same results if you keep the current this low. So right there, that's only showing a gain of like 1, or a gain of 10 basically. So let's pluck that out and check this one too. And so we also saw differences. So I'm going to put that in backwards based on whether it was a 2N3904 or the 2N2222. Right there. So that is the mistake. We'll turn this around. And there we go. That is the gain we expect in the hundreds of beta, basically. There's a number of different ways to talk about gain, but we're getting a little more than 300 times from collector to emitter from what we are setting from base to emitter. Right now, well, it's in the proper direction. Everything gets screwy when you put it in backwards. Now we're going base to collector with a set current. And so even though it's backwards, since the emitter is positive, it's going to work kind of the same. But the gain is thrown off. So I don't think it damaged anything, but you never know for sure. So we got that covered. And so I think I already showed you without a load, we saw it's unstable at higher currents. But even at lower currents, we're going to go back to the 6.8 kilo ohm resistor. Without a load, it's even more unstable without a resistor. So let's put the resistor back first to get our more stable reading. Right there. So there you can see we're putting in 1/10 of the current from base to emitter from what we were before. We have about 1/10 of the voltage approximately. Now we're going to yank this. That's what we expect. That's good for now. And I don't know where my red jumper went. So grab the blue one. The jumpers, it's just wire. The plastic's just a cover for it, insulation. But it's good to color code things as often as you can. And so there you can see, without a load, it's actually not holding too bad, it doesn't look like. So it may be more the amount of current that was going through the transistor, warming it up. Let's see if the 2N2222 is that stable. Right there. So this is, as you can see, all you need is a multimeter and the transistors and, you know, these basic components, and you get a better feel for how these components work when you just do these simple tests like that. So yeah, it's holding pretty steady like that. So I think before it was more erratic, but in any case, it's holding steady now, and so that's what's important. So in any case, these are just basic components. The multimeter, everybody that does electronics should have all, except for the current source. I bought this separately, but I really like them, and so I recommend getting them. The LM334 if you're really interested in electronics. But the 2N2222 and the 2N3904 are both pretty common. You can use other transistors, of course, do this same testing, but they may have a different pin layout. But as long as they're NPN Bipolar Junction Transistors, you can do this testing. Now, there's also this tester device here. So we're going to plop in a 2N3904. And so I'm not sure the testing parameters, as we just saw, different electrical properties give you somewhat different results. But there you can see the pin layout. So the left pin is 1, middle pin is 2, and then the pin to the right is 3 when you're looking at the flat side. So pin number 1, left pin, is the emitter, pin 2 is the base, and pin 3 is the collector. And there you can see the gain there. So the gain is higher, but I'm guessing that's because we put higher current. They're tested at higher current, or maybe lower current. So I'm not sure. And then, so now we'll do the same thing with the 2N2222. All you gotta do is lock it in place again, and then hit test right there. And you can see, same pin layout, NPN Bipolar Junction Transistor, and it's got about the same gain according to this, the way that it tested it. So the battery there too, I'm using probably a lithium ion battery, so it's slightly lower voltage, but it's still good enough for this meter. But again, pin 1, 2, 3, emitter, base, collector. 1, 2, 3, emitter, base, collector. So you can just do one of these testers, and I really recommend these testers if you're just beginning electronics, because as you can see, you can put transistors in there, so it's not always 100% accurate. It gets confused. Like we got the current source here, and let's plug the current source in, the LM334, and I don't think that it has a current source test to it. So it's gonna determine. It's some kind of component though, and based on its testing results, and it actually thinks it's an NPN bipolar junction transistor with a gain of 17. It thinks pin 1 is the collector, pin 2 is the emitter, so down there, and it thinks that pin 3, the right pin over there, is the base with the forward voltage, and so that's probably because when it tested it, it did get current pushed through it if it had just enough voltage to be able to supply that current. So that's probably what that was about. So in any case, transistors are pretty cool. You don't really need them once you get good with components, but they're pretty nice. You can also test resistors, and you can test capacitors. So let's do that test right there without the blinding light on there. And so it takes, I think it's close to 30 seconds or something. There you can see 680, but it's slightly lower. So you do have the tolerance. They're not exact components, especially these cheap ones. And so now a capacitor. We got to make sure it goes into 2 different pin numbers. It fell to the floor. So, oh well, we will just skip the capacitor. But in any case, you just got to put them in there, and it automatically tests them. Pretty straightforward. So this went way longer than I thought, but I still hope you found it interesting. Thanks for watching. I will see you in the next video.